Number 19, another interval convergence problem. Find all values of x in which this power series converges. So what do we do first? We always do the ratio test first. So limit as n goes to infinity, a sub n plus 1, divide by a sub n. So this is the setup here. Be careful with parentheses. Okay, so wherever there's an n, replace it with an n plus 1. So that's why there's these parentheses here. Got to be careful. Okay, so we start simplifying. Let's do the easy stuff first, like x minus 3 to the n plus 1 divided by x minus 3 to the n. Subtract the powers. You have x minus 3 to the first power. So we pull that out in front because it doesn't depend on n. Don't drop the absolute values, though. We don't know what x is. So we got to keep our options open. Okay, similarly, 4 to the n divided by 4 to the n plus 1. Subtract the powers. You have 4 to the minus 1 power, so 1/4. We can pull out in front. That's a constant for sure. Okay, so what's left? We have this n squared plus 2n plus 1 plus another one. So n squared plus 2n plus 2. We have n plus 1, and then we have n plus 2 on bottom, and n squared plus 1. Okay. So this is the trick for these problems. If you haven't figured it out at this point, just let me explain. This is a rational function inside this. I mean, it's like a rational function. So remember, the trick for those is we do the degree test. What's the highest degree on top? Well, if you expand everything out, the highest degree is n cubed. We care about the coefficient as well. So it'll be 1n cubed plus who cares what's after that. This is the highest power of n. That's all we care about. Similarly, for the bottom, it'll be n cubed as well, or 1n cubed. Okay? Degrees are the same. Take the ratio of the leading coefficients. That's just what? So the limit is 1. And we set the result of the limit. So 1 times x minus 3 in absolute value over 4, by the way, to be clear. So we set the result of the limit to be less than 1 per the ratio test, saying that this power series converges. Okay, so we start solving this inequality. X minus 3 in absolute values is less than 4. So the radius of convergence is 4, by the way. Okay. Now we start solving more. Remember, this is how we break up the absolute values. There's 2 options, right? And then we add 3 on both sides. So now we check our endpoint because remember, the concept is the ratio test is inconclusive at the endpoints because that's when the limit is exactly 1. That's why we got to check it manually. So we check x is -1. We plug in -1 right here into x. What do we get? We get minus 4 to the n. So the 4 to the n's will cancel, but you have a changing sign still. And then we have this n squared plus 1 over n plus 1 from this term, okay? Does the series converge? Does it diverge? Hopefully, you can immediately tell that it diverges by the test for divergence. We take the limit as n goes to infinity of this guy. It will oscillate between, well, it doesn't exist. Yeah, so it will oscillate between positive infinity and negative infinity. It keeps growing in the keeps growing either in the positive or it keeps growing in the negative. Okay. Now we check the other endpoint, x equals 7. So we would get 4 to the n if we plugged in x as 7. Okay. We cancel these 4 to the n's. We get this. This, again, we can tell right away, does not converge by the test for divergence. Again, the limit as n goes to infinity. This is infinite. It is not equal to 0. So that's why it diverges. Okay. Therefore, our interval convergence does not include the 2 endpoints, and we could just leave this inequality as is. So -1 less than x less than 7. Okay, so here's the example of a power series that does not converge at either of the endpoints versus the other 2 that I filmed as when I filmed this, the other 2 problems that I filmed, I think it was like 9 and 10 or something like that, in which one of them at both endpoints and converged, and the other one at one endpoint it converged, but the other it didn't. So here's one where it doesn't converge at either endpoint. Okay. All right. Again, this is a pretty typical level problem in my opinion, so you should know how to do this no matter what school you go to. I don't think there's any real tricks to this one. Okay. Hopefully this was another good practice problem. If you needed it, please give this video a like if it has helped you in any way, and please subscribe to see more content like this. Greatly supports the channel. Hopefully see you in another video as well. Bye.